Imagine tracing a single continuous line across East Africa from the warm Indian Ocean shoreline at Lamu in Kenya all the way inland to Juba, the capital of South Sudan. That is roughly 1,700 kilometers of imagined asphalt. Today we explore whether a four-lane highway along that corridor is feasible and what the land itself would demand in return. Look at this satellite view. You can see the coastal mangroves near Lamu, the dry savanna of northern Kenya, the wetlands approaching South Sudan, and scattered settlements connected by thin roads and dirt tracks. This is a grounded thought experiment, not an approved four-lane engineering plan. We will treat the map as our blackboard, and we will stay honest about uncertainty the entire way. Let us lay down the route concept. Our southern anchor is Lamu Port, part of the Real Lapset Corridor Initiative, which already envisions transport links towards South Sudan and Ethiopia. Our northern anchor is Juba, sitting near the White Nile. A straight line between them crosses northern Kenya near Garissa and Isiolo, brushes the border regions, and enters South Sudan through Nadapal and Nakadok, and on through Kapaweta toward Juba. But highways never follow straight lines. They bend around mountains, avoid floodplains, and chase gentle grades. This overlay shows a candidate corridor snapping toward existing towns and tracks. Following existing roads reduces land acquisition conflict and reuses cleared ground. But it can also add distance. Every kilometer we add is more cost, more maintenance, and more environmental exposure to justify. Now the terrain speaks. Look at this elevation profile drawn along the corridor. Lamu starts near sea level. The route climbs gradually across the Kenyan interior, rising toward the semi-arid plateaus that reach roughly 1,000 meters above the sea. As we approach South Sudan, the land undulates through hills before easing toward Juba, which sits around 460 meters elevation. The good news is that this is not a Himalayan crossing. There are no extreme mountain passes on the direct corridor. The challenge is not raw height, but the accumulated ups and downs. Each hill we cross adds cut and fill earthworks, and gentle, sustained grades are essential so that heavy trucks can climb safely without overheating brakes on the descent. Let us make slope intuitive with a quick animation. A highway ideally keeps grades below about 6%, and for comfortable high-speed traffic, closer to 4%. When the natural terrain is steeper than that, engineers must cut into hillsides, build embankments, or curve the alignment to stretch the climb across a longer distance. This slope heat map flags the steeper pixels in warm colors. Notice that most of the corridor is friendly, but pockets near hill ranges and river valleys light up. Those hot zones are where costs concentrate, because that is where you need retaining walls, deeper cuts, and careful drainage. A four-lane road roughly doubles the paved width compared to a simple two-lane track, so every steep section becomes much more expensive to carve. Water shapes roads more than hills do. This watershed map reveals the drainage systems our corridor must cross. In northern Kenya, seasonal rivers called lagas stay dry for months, then flash flood violently after rain far upstream. In South Sudan, we approach the White Nile system south of the vast Sud wetlands, one of the largest and most sensitive freshwater systems in Africa. Every blue line here is a potential bridge or major culvert. Undersized crossings wash away and strand communities. So we must map catchment areas, estimate peak flows, and design bridges for 100-year flood events. Keeping the route out of the deep Sud wetlands is not optional. It protects both the road and an irreplaceable ecosystem that millions of birds and large fish populations depend on. Beneath the surface, geology decides how hard construction becomes. This geology overlay hints at the mix along the corridor. Hard basement rock in places, loose alluvial soils near rivers, and expansive black cotton clays common in East Africa. Black cotton soil is a road builder's nightmare. It swells when wet and shrinks when dry, cracking pavement from below unless it is treated, stabilized, or replaced with stable material. Combine weak soils with intense seasonal rain, and you get erosion, gullying, and washouts. This risk zone map layers flood exposure, erosion potential, and slope instability into a single warning surface. Red corridors are where we would slow down, survey deeply, and possibly reroute. Remember, these layers are conceptual screening tools, not a substitute for boreholes and on-the-ground geotechnical testing. A highway is never only an engineering object. It is a social and ecological intervention. This risk zone map now highlights protected areas, conservancies, and wildlife corridors that intersect our route. Northern Kenya holds important rangelands and community conservancies, where elephants and other wildlife migrate seasonally. A 4-lane highway can slice migration paths, so we would need wildlife crossings, underpasses, and fencing strategies. Then there is land ownership. Much of this land is communal or pastoralist territory, and consent matters. Who benefits, who is displaced, and who bears the noise, dust, and safety risk? Ethical planning means free, prior, and informed consent, fair compensation, and honest environmental and social impact assessments before any bulldozer moves. Skipping that step creates conflict that no engineering can fix. So how long, how much, and is it worth it? Modern 4-lane highways in this region can cost very roughly $2 to $6 million per kilometer, more across wetlands, weak soils, and long bridges. Over 1,700 kilometers, a rough conceptual range lands in the several billion to well over $10 billion territory. Construction, if adequately funded and secure, could realistically take 8 to 15 years across phases, given surveys, financing, and difficult terrain. Economically, the upside is real. Lamu gives landlocked South Sudan a shorter route to the sea, cutting freight costs, boosting trade, agriculture, and oil logistics, and potentially supporting GDP growth over time. But benefits depend on security, maintenance funding, and honest governance. A road that is not maintained becomes a liability, not an asset. Let us turn concept into files you can open and inspect. Your downloadable bundle includes a Google Earth KML that draws the candidate corridor and key control points so you can fly the route in 3 dimensions and eyeball the terrain yourself. Here is the heart of that KML. It defines the endpoints at Lamu and Juba and a corridor line between them. Open it in Google Earth, tilt the view, and study where the line meets rivers and hills. This is a planning sketch for exploration and discussion, not a survey-grade alignment. Treat every coordinate as a starting question, not a final answer. The bundle also ships a lightweight Map Libre viewer using free open-free map tiles, so you can share the route in any browser without a paid map key. This snippet loads the same corridor as GeoJSON and paints it over an open base map. You can add your own layers like protected areas or flood zones by dropping in more GeoJSON files. Alongside this, a Cartopy Python script and a control point CSV let you generate clean, static maps for reports. Together, these deliverables give planners, educators, and learners a shared, editable starting point. All built on open data you are free to inspect, question, and improve. Let us bring it together. We imagined a 4-lane highway from Lamu to Juba, and the land taught us its rules. The elevation is manageable, but slope pockets, river crossings, black cotton soils, wetlands, and wildlife corridors are the real challenges. The cost runs into billions, the timeline into a decade or more, and the economic promise is genuine but conditional on security, maintenance, and fair governance. Most importantly, everything you saw is a conceptual screening, not an approval. The honest next steps are ground surveys, geotechnical boreholes, hydrological studies, full environmental and social impact assessments, and real community consent. Download the bundle, open the maps, challenge the route, and let the terrain keep teaching you. Good planning listens to the land first. Please see the references for further reading.